How the class structure will be there. First we'll start with the definition, then foundation level problems, then intermediate level problems, then advanced level problems. Finally, exam model questions. Finally, exam model questions. Each and every topic which I take, it will go through these 5 layers of learning mechanism, starting with the definition of a given concept, some basic questions to understand the concept, intermediate level problems, advanced level problems, and exam model problems. I spend a lot of time in doing a research on a particular topic. Probably few problems you might have solved it, but the kind of advanced level problems which I take is something which you will not find it in the regular textbooks. Highest powers. Now before we start, let me take some basic fundamentals. Factorial. Suppose if I write n factorial. Factorial is defined as the product of all n natural numbers from n to 1, n into, n minus 1 into, n minus 2 into, n minus 3, and so on up to 3 into 2 into 1. From 1 to n, if I take natural numbers and if I do the product, what I get is nothing but the factorial. Suppose if I take 4 factorial, 4 factorial can be written as 4 into 3 into 2 into 1. 4 into 3 into 2 into 1, answer is 24. 4 factorial means from 4, write all the natural numbers backward from 4 to 1. Factorial is defined for, it is defined for, what will be n? Factorial is defined for whole numbers. Factorial, it is defined for whole numbers. Factorial is defined for whole numbers. 0 factorial, it is 1. 0 factorial, it is 1. Now, how 0 factorial it is 1? Suppose there are 4 important identities related to NCR. NC0 is 1, NC1 is n, NCn equivalent to 1, NCn equivalent to 1, NCn equivalent to 1. Now NC2 is n into n minus 1 by 2, n into n minus 1 by 2. NC0 equivalent to 1, NC1 equivalent to n, NCn equivalent to 1, and NC2 equivalent to n into n minus 1 by 2. You don't need to by heart anything. For example, there are 4 students in the class. 4 students in the class. I entered into the class. All the 4 students got greater than 80%. All the 4 students got greater than 80%. I entered into the class and I told each one of them, how many students who got less than 80%? How many students got less than 80%? All of them got greater than 80%. So I entered into the class and I made that announcement. How many students got less than 80%? Planned stand up and move out. None of them move out. NC0. From n, I am not selecting any. From n, I am not selecting any. If I am not selecting any, I entered into the class, made an announcement, and I exited the class. None of them. Not selecting is also one of the ways of telling that not selecting any. That means I am rejecting all. Rejecting all is nothing but not selecting any. Rejecting all is nothing but there is only one way. Are you all with me? Rejecting all is nothing but selecting one. Suppose in mathematics, there are 4 options are given to you. 4 options are given to you. In how many ways can you attempt this question? Either you can say option A is right, or you can say option B is right, or you can say option C is right, or you can say option D is right. Or you can decide not to attempt this question. So in how many ways can you attempt this question? Attempting, I did not define it as tick marking option. Attempting means either I can choose option A or option B or option C or option D, and I decide not to tick mark any option. I decide not to tick mark any option. I decide not to tick mark any option. Totally, how many ways are there? 5 ways are there. 5 ways are there to attempt a question. Again, one more example. These examples should give you a lot of clarity. Suppose I went to attempt a CAT examination. I am done with all the biometric testing. I sat in front of the examination. I did not even attempted any question. All the time I was just looking at the question and appreciating the beauty of the question. I did not even attempted any question. So the invigilator said, or the timer said that last 1 minute left. I did not even attempted any question. At the end of the examination, I clicked on the submit button. Did I wrote the examination? Yes. Did I attempted any question in the examination? No. I just went there and clicked the submit button and I came out. Did I attempted the examination? Yes. Did I attempted any questions in the examination? No. That means I did not attempt any question in the examination, but I went and wrote the examination. I hope you are able to understand. So in how many ways can I answer this question? I went to the examination. There is one question. Either I can tick mark option A or option B or option C or option D. I did not tick mark anything. Total how many ways are there? 5 ways. Same corollary. NC 0. I entered into the class. I said, how many of you got less than 80%? None of them got. I exited the class. I entered into the class and made that announcement. But I did not selected any. So there is only one way. None of them got selected. None of them got selected. I hope the idea it is clear. None of them got selected. None of them got selected. Idea clear? NCN equivalent to 1. I entered into the class. I said, how many of you got greater than 80%? Everybody stood up. I said, come, let's have fun outside the class today. In how many ways? All of them can be selected. In how many ways? All of them can be selected. All of them can be selected. It is 1. In how many ways? All of them are selected. It is only 1. I entered into the class and I said each and every one, there is no class today, which generally I will not say. Come, let's play outside the office and let's play in the ground. So all of them are selected. It is 1 way. None of them are selected. It is 1 way. And all of them are selected. It is also 1 way. Are you all with me? Suppose if I take, what is the definition of NCR? N factorial by n minus r factorial into r factorial. Suppose if I take NCN, it is n factorial by n minus n factorial into n factorial. Are you all with me? You should not, when I write 0 factorial equivalent to 1, immediately you should get a doubt. Why 0 factorial should be equivalent to 1? What is the proof behind it? I am discussing the proof. NCN, it is 1. N factorial cancels out. 0 factorial equivalent to 1. 0 factorial equivalent to 1. I hope mathematical proof it is clear to you. Each and everything, whatever I am going to explain in class, I am going to give a very detailed explanation for every important concept. NCN equivalent to n factorial by n minus n factorial and n factorial. N factorial cancels out. 0 factorial equivalent to 1. 0 factorial equivalent to 1. None of them got selected. None of them. Even you can use this concept also. N factorial by n minus 0 factorial. N factorial into 0 factorial equivalent to 1. So the answer is 0 factorial equivalent to 1. I hope the idea it is clear. NC1 equivalent to 1. N. I entered into the class. There are 4 students sitting in the class. I selected 1. That first student can be student 1. Or the first student can be student 2, or the first student can be student 3, or the first student can be student 4. I entered into the class. I need to select one student. NC1 is selecting one student out of n student. I need to select one student out of 4 students. It could be student 1 or student 2 or student 3 or student 4 or. Whenever there is a choice, we use the English word or, and we use the fundamental principle of addition. We use fundamental principle of addition. Whenever there is a choice, we use or condition or fundamental principle of addition. Suppose Anil Nair, he is at location A. I need to go to location B. I have 2 choices via train. I have 3 choices via bus, or probably I can go by bus, I can go by train, I can go by scooty, I can go by plane, and I can go by lorry. For example, from location A to location B, I can go by 5 ways. Either I can go by bus or I can go by train. I have a choice. I can go by scooty, or I can go by plane, or I can go by lorry. I have a choice to make. Either I can choose any one out of these 5. I have a choice to make. Whenever there is a choice to make, I will use or condition. Or condition is nothing but addition. Or condition is nothing but addition. One way, through bike or through train or scooty or through plane or through lorry. So total how many ways are there? 5 ways are there. I need to select 1 out of 4. I need to select 1 out of 4. Either 1 or 2 or 3 or 4. So our condition it is there. Our condition is nothing but plus. Either 1 or 2 or 3 or 4. There are 5 ways. 1 plus 1 plus 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1 plus 1. If there are 4, I got 4 choices to make. If I need to select 1 out of n, I have an n choices to make. Answer is n. I hope the idea it is clear. NC0, it is 1. NC1. NC1 is defined as n. Why we got n? I am selecting 1 out of n. That one could be the first one, or second one, or third one, or fourth one, or it could be nth one. So NC1 is equivalent to n. NC0 equivalent to 1, NC1 equivalent to n, NCn equivalent to 1. Again, I am repeating this fundamental key points, sir, because factorial related problems are extremely important and they are derived from NPR and NCR. Not selecting any, there is only one way. Selecting 1 out of n, first or second or third, it is n. Selecting all out of all, selecting all out of all, it is 1. NC2, it is n into n minus 1 by 2. So NC2, either I can select first and second, or first and third, or first and fourth, or I can select second and third, or second and fourth, or I can do third and fourth. Third and fourth. Totally how many ways are there? Totally 6 ways are there. Suppose on 4 I am selecting 2. Suppose if I choose 1, 1 can go with 2, 1 can go with 3, 1 can go with 4. So the first person can go with any of the other 3 persons. Second person can go with other 3. Each one has got 3 cases. 3 into 3 into 3 plus choice. 1 with 2, 1 with 3, 1 with 4. 3 cases. Or 2 with 1, 2 with 3, 2 with 4. 3 cases. Or 3. 3 plus 3 plus 3 plus 3. Half of them are duplicated. Half of them are duplicated. If there are n, 1 with other n minus 1, 2 with other n minus 1, 3 with other n minus 1, 4 with other n minus 1. Total n, each one with n minus 1. N into n minus 1. Half of them are duplicated. So n into n minus 1 by 2. n into n minus 1 by 2. Very, very important key point. In this slide, we have discussed why NC is 0 equivalent to 1. Not selecting any, there is only one way. NC n equivalent to 1. Selecting all out of all, there is one way. NC 1 equivalent to n. Selecting 1 out of n. It could be first, it could be second, it could be third, or it could be nth one. So there is a choice to make. Wherever there is a choice to make, I will use or keyword from English, or I will use fundamental principle of multiplication. Fundamental principle of, multiplication is for and. Fundamental principle of multiplication, when there is no choice to make. When there is no choice to make, and keyword it is there. Whenever there is no choice, I will use fundamental principle of multiplication. Underline these important keyword. In permutation and combination, good number of problems only we are going to solve based upon, is there any choice in the question, or is there no choice in the question? If there is a choice in the question, I will add it. If there is no choice in the question, I will multiply it. I hope this concept it is clear. I hope this concept it is clear. Now see here. Idea it is clear, right? Now we will solve some important problems based upon fundamentals. Based on fundamentals. 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 First we'll write fundamental here. N factorial. N factorial, it is the product of all natural numbers from n to 1. Product of all natural numbers from n to 1. N into n minus 1 into n minus 2, and so on up to 3 into 2 into 1. For example, I want a 3 factorial. 3 factorial it is 3 into 2 into 1, which is 6. 3 factorial contains a prime number 3. Make a note of it. That means 6 is divisible by 3. 4 factorial. 4 into 3 into 2 into 1. 3 into 2 into 1, 6, 6 4s are 24. Now see here, 4 factorial. These 3 into 2 into 1, it is 3 factorial. So it is 4 into 3 factorial. 4 into 3 factorial. 5 factorial. Product of all natural numbers from 5 to 1. 5 into 4 into 3 into 2 into 1. This is 4 factorial. It is 5 into 4 factorial. 4 factorial is 4 into 3 factorial. 4 into 3 factorial. Are you all with me? 4 into 3 factorial. Now very, very important. 3 factorial contains 3. The next natural number, 4 factorial contains 3. The next natural number, 5 factorial contains 3. Very, very important key point. N factorial is always divisible by 3. N factorial is always divisible by 3. N greater than or equivalent to 3. Make a note of it. This question is based upon that. N factorial is always divisible by 3. N factorial, it is always divisible by 3. First point. The second point is, 5 factorial, 5 into, 4 into, 3 into, 2 into 1. These 2 5s are 10. Any number multiplied by 10, answer unit digit, it is 0. Answer unit digit, it is 0. That means from 5 factorial onwards, n factorial onwards, it is always divisible by 10. N greater than or equivalent to 5. Make a note of it, sir. N factorial, it is always divisible by 10. N greater than or equivalent to 5. I will come back to each and every key point by taking some very, very good question. Factorial. A factorial is defined as the product of all natural numbers from n to 1. A factorial is defined as product of all natural numbers from n to 1. Some simple calculation based questions. Some simple calculation based questions. Some simple calculation based questions. Now see here. Listen carefully. 2 questions. First question. Q equivalent to 1 factorial plus 2 factorial plus 3 factorial and so on up to n factorial. 1 factorial plus 2 factorial plus 3 factorial and so on up to n factorial. How many values n can take such that q is a perfect square? Such that q is a perfect square. Q is 1 factorial plus 2 factorial plus 3 factorial and so on up to n factorial. How many values n can take such that q is a perfect square? A CAT replica question. Q equivalent to 1 factorial plus 2 factorial. We'll create as many questions as possible on spot so that students will learn how to solve questions which are probably not there in the PPT also. How many values of n will take such that q is a perfect square? If I take 1 factorial 1, it is a perfect square. If I take first two terms, 1 factorial plus 2 factorial, 1 plus 2, 3. 3 is not a perfect square. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. 3 numbers. 1 factorial plus 2 factorial plus 3. 2 plus 1, 3. 3 plus 6, 9. 9 it is a perfect square. Next, 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. 1 factorial it is 1, 2 factorial 2, 3 factorial 6, 4 factorial 24, 9 plus 24, 33. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. A lot of problems we discussed. Perfect square, we have done so many sessions which uses this concept. 1 plus 2, 3 factorial, 24. How to compute? 4 factorial is 4 into 3 into 2 into 1, 24. 24 plus 6 plus 2 plus 1, which is 33. 5 factorial onwards. What is that we discussed? Till 4 factorial, 5 factorial. 5 factorial ends with, what is the unit digit? 0. This is 0. 4 factorial till 1. What is the sum unit digit? 3. 3 plus 0, it is 3. 3. 5 factorial unit digit, it is 0. 1 to 4 factorial sum unit digit, it is 3. 3 plus 0, it is 3. That means from 5 factorial onwards, 6 factorial, 7 factorial, 8 factorial, all the numbers unit digit will be 0. 0 plus 3. 0 plus 3, it is 3. A perfect square unit digit will never be 2, 3, 7 or 8. A perfect square unit digit will never be 2, 3, 7 or 8. How many values it is taking? N equivalent to 1 it is taking, n equivalent to 3. That means sum of the first one natural numbers it is taking and sum of the first 3 natural numbers factorial it is taking. Remaining all the cases, it is unit digit 3. Unit digit 3. 5 factorial onward, unit digit 0. How many values n will take such that these expression will result in a perfect square? How many values? N value 1 and n value 3. Put a star mark on this question because we discussed the definition of a factorial. Let us solve the question. A smart student might ask me a doubt. Sir, what if factorials are not given? How to solve that question? Write down that question also, sir. Write down that questions. Not a single doubt, you will get it in my class. Suppose if the question is Q equivalent to 1 plus 2 plus 3 and so on up to n, and it is giving not a perfect square, let us take it as triple A. What is the value of n and what is the value of A? Q equivalent to sum of the first n natural numbers, or the question is like this: sum of the first n natural numbers. Sum of the first n natural numbers. First n, so that it is starting from 1. It is a 3-digit number where all the digits are equal. Sum of the first n natural numbers. It is a 3-digit number where all the digits are equal. Find A and find n. Find A and find n. Find a and find n. 1 to n, sum of the first n natural numbers, it is n into n plus 1 by 2. n into n plus 1 by 2. In case if you want the proof, q equivalent to 1 plus 2 plus 3 and so on up to n. Reverse write down n plus n minus 1 and so on up to 1. Q plus q, 2q. It is n plus 1. n minus 1 plus 2, n plus 1 added n times. So it is n plus 1 added n times. It is n into n plus 1. Q will be n into n plus 1 divided by 2. Sum of the first n natural numbers. Proof is given by n into n plus 1 by 2. n into n plus 1 by 2. n into n plus 1 by 2. Listen carefully, sir. n into n plus 1 by 2. It is a 3-digit number where all the digits are equal. n into n plus 1 by 2 is a triple A. Cross multiplication. n into n plus 1 equivalent to 2 into triple A is A into 37 into 3. 37 3s are triple 1. Triple A can be written as A into triple 1. A into triple 1. Triple 1 is 37 into 3. Next step, we will get the answer. n into n plus 1 is 6A into 37. n into n plus 1 is 6A into 37. Now, if you see here, these both are consecutive numbers. These both should also be consecutive. n and n plus 1 both are consecutive. 6A and 37 both should be consecutive. What is the consecutive number to 37? Either it can be 36 or 38. 37 could be the first number, next number will be 38. 36 could be the first number, next number could be 37. And this is a multiple of 6. So 38 is not a multiple of 6. 38 is not a multiple of 6. Over. So n value, it is 36. n is 6A. A value will be 6. n is 36 and A value 6. n is 36 and A value 6. I hope the idea, it is clear. Is the idea clear to you? Is it clear to you? Q equivalent to 1 plus 2 plus 3 and so on up to n. Seems like a crypt arithmetic question where we are decoding the variables into numerical values. 1 plus 2 plus 3 and so on up to n. n into n plus 1 by 2. It is a triple A. Cross multiplication 2 into triple A. Triple A can be written as A into triple 1. Triple 1 is 37 into 3. 2 into 3, 6, 6 into A, 6A. 6A into 37. These both are consecutive numbers. These both should also be consecutive. So, consecutive to 37 is 36. N value 36. 6A, it is 36. A value, it is 6. A value, it is 6. I hope the idea, it is clear. Another CAT replica question. Please put a star mark. Please put a star mark. I hope the idea, it is clear, right? Next, another question. This is a CAT level question. X square minus, for example, 11y factorial equivalent to 2003. X and y are natural numbers. How many values xy will take such that this equation is satisfied? X square minus 11y factorial equivalent to 2003. xy are natural numbers. How many values xy will take such that this equation is satisfied? First thing is, read the question again. X square, it is a perfect square. Y factorial, it is factorial based question. A perfect square never ends with 2, 3, 7, all right? And y factorial, it is a natural number. Y value 1. X square minus 11 equivalent to 2003. X square equivalent to 2014. A perfect square will never be of the form 4k plus 2. 14 when divided by 4. 4 3s are 12. Remainder 2. It is not possible. Y equivalent to 2. X square minus 22 equivalent to 2003. X square equivalent to 2025. X is 45. 45 square is 2025. 45 square is 2025. So that can be the answer. Y equivalent to 3. X square minus 66 equivalent to 2003. X square equivalent to 2069. 3 factorial, it is 6. 6 into 11 is 66. 2003 plus 66, it is 2069. Is 2069 a perfect square? What is the digital sum of these number? 6 plus 2, 8, 8 plus 9, 17. The digital sum perfect square is always 1, 4, 7 or 9. It is not possible. It is not possible. X square, y equivalent to 4. X square minus 11 into 4 factorial equivalent to 2003. 4 factorial, it is divisible by 4. It is remainder 3. Can a perfect square will have of the form 4k plus 3? Not possible. Please don't waste your time in computing 4 factorial and writing down it as 4 into 3 into 2 into 1. I hope it is clear. Now if you see, y factorial ends with zeros. Y factorial ends with zeros. Y greater than or equivalent to 5. So if I solve this question, y 5 factorial, it is ending with 0. 0 into anything 0. 0 plus 3, 3. 6 factorial, it is ending with 0. 0 plus 3, 3. That means x square equivalent to 2003 plus 11y factorial. 5 factorial 0, 0 plus 3, 3. 6 factorial 0 plus 3, 3. All these numbers will have unit digit 3. Can a perfect square has unit digit 3? A perfect square will not have unit digit 3. So that can be eliminated. That can be eliminated. So how many values we got? We got one value. X is 45 and y is 2. X is 45, y is 2. Very, very good question. Seems like it is a difficult question, but actually it's an easy question if you understand. X and y are natural numbers. Y value 1. X square minus 11 equivalent to 2003. X square is 2014. 14 is 4 into 3 plus 2. A perfect square, when divided by 4, it can never give a remainder 2. First option out. Second option, x square minus 22 is 2003. X square is 2025. X is 45. 45 square is 2025. Second could be y is 3. X square minus 66 is 2003. 2003 plus 66. 2016, 9. Digital sum of these number is 8. If it is a perfect square, it will have digital sum 1, 4, 7 or 9. Y is 4. These are divisible by 4. 4 factorial is divisible by 4. If it comes to the right hand side, 2003, it gives a remainder 3. 4k plus 3, not possible. Y factorial onwards. 5 factorial, unit digit 0. 0 plus 3, 3. 6 factorial, unit digit 3. It is 0 plus 3, 3. And so on, the process continues. Very, very good basic foundation questions that we did it based upon this value. Question. 3 questions, 3 extra questions we did it. I hope everything is clear. Let me see it in my mobile. Whether are there any technical issues students are facing? Just give me 1 minute, sir. I hope there are no issues. Kindly make a note of these notes. Right. There are no issues. Now, suppose a student might ask me a doubt. Sir, Anil sir, here we did sum of the first and natural numbers. I am unable to remember. Suppose if the question is 1 square plus 3 square plus 5 square plus 7 square plus 9 square plus 11 square. 1 square plus 3 square plus 5 square plus 7 square plus 11 square equivalent to n. What is the value of n? What is the value of n? Because in my tuition classes or online classes, only these formulas are given. Till n square it is n into n plus 1 into 2n plus 1 divided by 6. But it is of the form 1 square plus 3 square plus 5 square plus 7 square and so on up to 11 square. These formula I have not seen in any of the textbook. And without using formulae, is there any logic that we can do it? 1 cube plus 3 cube plus another notation. 5 cube plus 7 cube plus 9 cube plus 11 cube. How to find out the value of n if answer options are present? If answer options are present, how to find out? Now the best way to solve this problem is, listen carefully, sir. Listen carefully. 1 square plus 3 square plus 5 square plus 7 square plus 9 square plus 11 square. It is not the questions which are important in my class. The way I solve each and every question, that is why the students purchase the course. The structure is extremely important. Anil Nair's way of solving. 1 square plus 3 square plus 5 square plus 7 square plus 9 square plus 11 square. Now we want the answer. N value we want. There are two ways to check this one. The first thing is use a digital sum approach. Play with the answer option. Use a digital sum. Listen carefully. 3 square is 9. What is the first concept? 9k plus x equivalent to y. X and y digital sum will be same. 9k plus x equivalent to y. Digital sum of the number which is getting added to 9 or multiples of 9. Digital sum will be same. 9k plus x equivalent to y. X and y digital sum will be same. These also x and y 9 square it is 81. So you can first thing omit all the values where the digital sum is 9. 1 square it is 1. 25 it is 7. 7 square 49. 9 is omitted 4. 11 square 121. Digital sum is 4. So answer digital sum should be 4 plus 1 9 out. Answer digital sum should be 7. I hope the idea it is clear. Answer digital sum should be 7. Answer digital sum should be 7. Answer digital sum should be 7. Idea it is clear. The second thing is, these and 1 square it is an odd number. 3 square it is an odd number. Odd plus odd even. Odd plus odd even. Odd plus odd even. Odd plus odd plus odd plus odd plus odd plus odd. So answer will be even. That means answer, if there is an odd number, please eliminate it. Why? Because if I am adding even number of odd numbers, answer will be even. Odd plus odd even. Odd plus odd even. Odd plus odd even. Answer will be even. Digital sum of the question should be 7 and the answer should be an even number. If there are more options with even, then you can use unit digit. Then you can use the unit digit logic. 1 square it is 1. 3 square 9. 5 square 25. 7 square 49. 9 square 81. 11 square 121. 9 plus 1 10. 9 plus 1 10. 9 plus 1 10. I hope the idea it is clear. So answer digital sum will be 1 plus 5 6. You do not need to by heart the formula for everything. If you know some better approaches, you can actually play around with the answer option. 1 square plus 3 square plus 5 square plus 7 square plus 9 square plus 11 square. Suppose without formula, how to solve? Odd number plus odd number, even number. Odd plus odd, even number. Odd plus odd, even number. Answer should be an even number. Answer should be an even number. If there is an answer option odd, eliminate it. Next, remove all the options where the power digital sum will be 9. 3 square 9 out. 9 square 81 out. 1 square it is 1. 5 square 25. 2 plus 5 7. 7 square 49. 4. 11 square, 121, it is 4. 4 plus 1 out. What is the answer digital sum? 7. Answer digital sum should be 7 and it should be an even number. In case if there are more options with answer even, use the unit digit logic. Use the unit digit logic. So even this is also, suppose let me do with a simple example. 1 square plus 2 square plus 3 square plus 5 square. Let me see if all the answer options are matching with the formula whatever we knew it. 1 square plus 2 square plus 3 square plus 4 square plus 5 square. If I use these formulae, n into n plus 1 into 2n plus 1 divided by 6, answer is 55. n into n plus 1 into 2n plus 1 divided by 6. 5 11s are 55. Let us check with this one. First thing, 3 square it is 9. First I am using digital sum. 1 square it is 1. 2 square 4. 4 square 16, 7. 5 square 25, 7. 7 plus 7, 14. 14 plus 4, 18. 18 plus 1, 19. 19 digital sum is 1. 19 digital sum is 1. 5 plus 5, 10. What is the digital sum? 1. Digital sum 1. Next, it is an odd number. Even number. Odd plus even, it is odd. Odd plus even, it is odd. 5 is an odd number. Odd plus odd plus odd. Answer should be an odd number. 55, it is an odd number. Second one, also it is, in case if you want the unit digit, 1 square plus 3 square, 9 plus 1, 10, 0. 4 square, 2 square, 4, 4 square, 16, 4 plus 6, 10, 0. 5 square, 25, 0 plus 5. It is 5. Unit digit has to be 5. Unit digit has to be 5. 55. Unit digit it is 5. I hope the idea it is clear. You don't need a mathematical formula to solve each and every question. All you do is just look at the question through a common sense, you will find a better ideas. Now you can solve this question very, very easily. Very, very easily. So it is not only sum of the first and natural numbers. Square is given. Numbers are not in AP. Numbers are in a different patterns. Numbers are not following a fixed order. Always you can use the digital sum concept. Please put a star mark on this concept. This will help you to solve the questions without using formulae and probably the fastest approach. Again, I am repeating. 3 approaches you can use. Digital sum, check it out. Unit digit, check it out. And a number tree, you can check it out. In fact, you can use one more logic if the power is an odd number. If the power is an odd number. If the power is an odd number. And A1 power K, A2 power K, A3 power K, and so on up to AN power K. A1, A2, A3 and so on up to AN are in arithmetic progression. Then these always divisible by sum of the bases. I discussed this in reminder session number 5 or 6. 5 or 6. If the power is an odd number, A1 power K plus A2 power K plus A3 power K. If the bases are following a particular pattern, that pattern is in arithmetic progression, then the series is always divisible by sum of the bases. What are the sum of the bases? A1 plus A2 plus A3 and so on up to AN. Only to discuss this concept, this problem is given. Power is an odd number. N is 3, which is an odd number. 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11. It is always divisible by sum of the bases. Sum of the bases is 1 plus 3 plus 5 plus 7 plus 9 plus 11. 1 plus 11, 12. 3 plus 9, 12. 5 plus 7, 12. Answer will be divisible by 36. 36 means it should be divisible by 4 into 9. 4 into 9. That means the last two digits of the answer should be divisible by 4 and the sum of the digits should be divisible by 9. Sum of the digits, it should be divisible by 9. I hope the idea it is clear. Sir, from where it is derived? Why it should be divisible by sum of the bases? Now see here. A power n plus b power n. A power n plus b power n. If n is odd, it is divisible by sum of a plus b. 1 power 3 plus 11 power 3. 1 power 3 plus 11 power 3. It is divisible by 1 plus 11 because power is an odd number. 3 power 3 plus 9 power 3. It is divisible by 3 plus 9. A power n plus b power n. It is always divisible by a plus b. A power n plus b power n. It is always divisible by a plus b if n is an odd number. So 1 plus 11 I got, 3 plus 9 I got, 5 plus 7 I got, which is nothing but the sum of the bases. Which is nothing but the sum of the bases. I hope the idea it is crystal clear to you. If the k is an odd number, this is a very, very important key point. Make a note in your notebook. If k it is an odd number, if k it is an odd number, if k it is an odd number and the base values are in arithmetic progression, base values are in arithmetic progression, it is divisible by the sum of the bases. Power is 3. It is an odd number. 1, 3, 5, 7, 9, 11. All the base values have a difference too. They are in arithmetic progression. They are in arithmetic progression. So it is divisible by sum of the bases. Why it is divisible by sum of the bases? First and last. A power n plus b power n. I will write down that concept here. A power n plus b power n is always divisible by a plus b if n is an odd number. If n is an odd number. A cube plus b cube. It is a plus b into a square minus ab plus b square. I hope the idea it is crystal clear. First and last divisible by 12. Second and second last divisible by 12. Third and third last divisible by 12. Divisible by 12. I hope the idea it is clear. Why it should be sum of the first and natural numbers? If it is squares of the first and natural numbers, what if it is not squares of the first and natural numbers? What if it is not squares of the first and natural numbers? Let me create one more question if there is a space. Yes. Suppose if the question is 1 power 5 plus 3 power 5 plus 5 power 5 plus 7 power 5. 1 power 5 plus 3 power 5 plus 5 power 5 plus 7 power 5. 5 is an odd number. 5 is an odd number. 1, 3, 5, 7. 1, 3, 5, 7, they are in arithmetic progression. So it is always divisible by sum of the bases. 1 plus 7, 8. 5 plus 3, 8. Answer is divisible by 16. Answer is divisible by 16. I hope the idea it is clear. Answer is divisible by 16. What is the divisibility rule of 16? 2 divisibility rule is 2 power 1. Unit digit should be divisible by 2. 4 divisibility rule is 2 square. Last 2 digits should be divisible by 2. 8 is 2 cube. Last 3 digits should be divisible by 2. 16 is 2 power 4. Last 4 digits should be divisible by 16. 4 digits should be divisible by 16. I hope the idea it is clear. Basic foundation questions related to the definition of a factorial and some other questions. With now another important key point. Another important key point. Listen carefully here, sir. 6 factorial. It is 6 into 5 into 4 into 3 into 2 into 1. 2 into 1. 3 6 are 18. 18, what is the digital sum? 9. So answer digital sum. Answer digital sum. 6 factorial. N factorial onwards. Please make a note, sir. Every key point I am going to use it. N factorial digital sum will always be 9. N greater than or equivalent to 6. Make a note of it. n factorial. Which all factorial numbers will have digital sum 9? From 6 factorial onwards, all the digital sum will be 9. 6 3s are 18. 18 is 2 into 9. 9 into any number, answer digital sum will be 9. 9 into any number, answer digital sum will be 9. I hope it is clear. Now we will solve all the problems. Till now, each and every question it is clear. My sincere recommendation to all the students who are watching this class, it involves a revision of this class within 24 hours after the class is over. My class, there will be no entertainment in the class, no fun element in the class. I am a teacher, my job is to teach. That's what I will do. That's what I will do. Your job is to learn as much as possible. In case if you got a doubts facility is always there for the enrolled students. There is a separate Telegram group. You can keep your doubts. As soon as I become free, I personally will solve the doubts and I will reply it. I hope the idea it is clear. Now we will solve the first questions. Find the remainder one. 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. It is divided by 6. It is an introductory question. There is another question which I want to solve based upon this. 1 factorial plus 2 factorial, 3 factorial and so on up to 100 factorial. It is divided by 6. It is divided by 6. 3 factorial onwards. 3 factorial it is. 3 factorial it is. Divisible by 6. 3 factorial it is. 3 into 2 into 1. So 4 factorial is 4 into 3 factorial. All are divisible by 6. 1 plus 2 it is 3. 3 divided by 6. Numerator less than the denominator. Numerator itself will be the answer. 3 factorial divisible by 6. 4 factorial. 4 into 3 into 2 into 1 divisible by 6. 100 factorial. From 3 factorial, every other factorial after 3 will contain 3 factorial. Answer is 3. For me, this is not important. It is an basic foundation question. Let me solve the second question. The third question which I want to solve is, I will take the question here. The third question is, question goes like this. 1 factorial whole cube plus 2 factorial whole cube plus 3 factorial whole cube plus 4 factorial whole cube and so on up to 1152 factorial whole cube divided by 1152. Divided by 1152. 1 factorial whole cube plus 2 factorial whole cube plus 3 factorial whole cube plus 4 factorial whole cube and so on up to 1152 factorial whole cube divided by 1152. This is the question a student has asked me as a doubt. So before that one, I took an introductory question. Very, very good question it is, sir. 1152. Now see here. 1152. 1152, it is 576 into 2. 576, it is 24 square into 2. 24 square is 576. Now if you see 4 factorial whole cube. 4 factorial is 24 cube. 24 cube is 24 into 24 square. That means, is 1152 a part of this number? Definitely. 24 square is a part. 24 can be written as 2 into 12. We will write it like this. 2 into 24 square into 12. Am I right? So 24 square into 2. It is a part of 4 factorial whole cube. It is a part of 4 factorial whole cube. If it is 5 factorial whole cube, it is 5 into 4 factorial whole cube. 4 factorial whole cube. It is divisible by 24 square into 2. It is divisible by 24 square into 2. And so on. The process continues. From 4 factorial whole cube. All the numbers are divisible by 1152. 4 factorial, it is 24. 24 cube is 24 square into 2. 24 square, 1152, it is 576 into 2. 24 square into 2. 4 factorial is 24 cube. 24 cube is divisible by 24 square as well as 2. I hope the idea it is clear. So 1 factorial, it is 1. 2 factorial 2. 2, it is 8. 3 factorial, it is 6. 216. So answer for this question is 216 plus 9. Answer it is 225. Answer for this question is 225. It is a CAT replica question. CAT replica question. You can easily solve it. Probably if the options are 225, 225. If it is 215 and it is 235, or it is none of this. If the options are like this, if the options are like this, if you are an Anil Nair student, how you will probably solve this question? 1152. 1152, it is 1152. It is 2 into 576. 576. 576. 576 is 24 square. 8 into 3, 8 into 3. Yes or no? So it is 2 into 9 into 64. 2 into 9 into 64. 2 into 9 into 64. These numbers should be divisible by 2 into 9 into 64. 3 factorial onwards, digital sum is 9. 2 factorial, it is 2. 2 cube, 8. 8 plus 1, 9. Perfectly divisible by 9. Answer digital sum should be 9. Answer digital sum should be 9. Are you all with me? If it is 2, if it is 2 factorial, it is divisible by 2. All the numbers are divisible by 2. Remainder 1. Answer when divided by 2, it gives a remainder 1. Answer 1 is perfectly divisible by 9. Play around with the answer option. Play around with the answer option. What is the concept that I used here? I used the concept of Chinese remainder theorem. What is Chinese remainder theorem? Write the composite number as a power of co-prime numbers. As a power of co-prime numbers. In case if this logic does not strike, 1152 is 2 into 576. 576 is 24 square. 8 into 3, 8 into 3. 3 into 3, it is 9. So you can do it as 128 into 9. 128 into 9. Just to check whether 128, it is 2 power 7. Last 7 digits should be divisible by 128. If a number is not divisible by 2, how can it be divisible by 4? If a number is not divisible by 4, how can it be divisible by 8? So if a number it is, I am checking it for 2 and 64, then I will do it for 128. You can write the number as a product of non-co-primes. And if there are no options which will satisfy, then directly you will get this answer. I discussed how to do 63. Actually, you need to write it as 9 into 7. Even if you write it as 3 into 3 into 7. If a number is not divisible by 3, how can it be divisible by 9? So you can counter use that logic to eliminate the answer option. You can write 128 into 9, or you can probably do it as 2 into 9 into 64. Answer is, it should be divisible by 9. B, C and D are out. 225, it is the answer. If there is another option with the answer digital sum 9, then you will go with 128. I hope the idea it is clear. For you to make you understand this idea, let me do one more question. 6. 6 is nothing but 2 into 3. 6 is nothing but 2 into 3. If the options are like this, 3, 4, 2 and 5. 3, 4, 2, 5. Whenever you divide a number by 6, you will get the reminders from 0 to 5. 3, 4, 2, 5. If the options are like this, in fact, if you forget this logic, you can use this logic also. Check it out for 2. From 2 factorial onwards, all are divisible by 2. All are divisible by 2. So all are divisible by 2, remainder 1. Answer when divided by 2, it gives a remainder 1. Answer when divided by 2, it gives a remainder 1. 2 and 4 not possible. 2 and 4 not possible. 3. 3 factorial onwards, all are divisible by 3. 2 factorial it is 2. 2 plus 1 it is 3. Answer should be perfectly divisible by 3. Answer should be perfectly divisible by 3. Only option 3. Only option 3. Whenever you divide a number by 6, what are all the reminders possible? 0, 1, 2, 3, 4, 5. In 0, 1, 2, 3, 4, 5, what is the number that is perfectly divisible by 3? That is 3. So if answer options are there, you can convert the denominator into product of coprimes and you can solve it. Again, I am repeating. 6 is 2 into 3. First to divide these number by 2. 2 factorial onwards, all are divisible by 2. 3 factorial onwards, all are divisible by 3. Remainder, it is 1. So it is 2a plus 1. 3 factorial onwards, all are divisible by 3. 2 factorial, it is 2. 1 factorial, 1. 1 plus 2, 3. Answer will be divisible by 3. Check by using answer option. Check by using answer option. Now see here, each and every concept, whatever I'm solving, if you do not attend this class, you would have probably solved it by just a natural way. What if denominator is a big number? What if the power is numerator, it is a big number? I'm telling you some optimal approaches. Method 1. Method 1. Question is 1 factorial square, 2 factorial square, 3 factorial square, and so on up to 50 factorial square divided by 18. Divided by 18. 3 factorial. 3 factorial is 3 into 2 into 1. 3 into 2 is 6. 6 square, it is 36. So all are divisible. 2 factorial, it is 2. 2 plus 1, 2 square, it is 4. 4 plus 1, it is 5. Answer will be 5. Again, I am repeating. 3 factorial, it is 6. 6 square, 36. 36 is an multiple of 18. So from 3 factorial onwards, all are divisible by 18. 2 factorial, it is 2. 2 square, it is 4. 4 plus 1, it is 5. This is one way. In case if you want to check by using answer options, 18 it is 2 into 9. 18 it is 2 into 9. 18 it is 2 into 9. What is that we discussed? Now see here. 2 into 9. So 2 factorial onwards, all are divisible by 2. It gives a remainder 1. Answer when divided by 2, it gives a remainder 1. Answer when divided by 2, it gives a remainder 1. 3 factorial, it is 6. 6 square, it is 36. 4 into 3 factorial whole square, 36 it is 9. Answer, it will be divisible by 9. 5 factorial, 5 into 4 into 3 factorial, divisible by 9. So it will be 1 plus 2 factorial 2. 2 2s are 4. 2 2s are 4. Answer when divided by 9, it gives a remainder 5. Answer when divided by 9, it gives a remainder 5. Which option will satisfy both? Please tick mark. There cannot be 2 answer options which will satisfy. In case if you get 2 answer options which will satisfy, answer could be greater than 18. When you divide a number by 18, you will get all the possible reminders from 0 to 7. Or you can go further. 9 can be written as 3 into 3. This is perfectly divisible. 2 factorial, it is 2. 2 square, 4. 4 plus 1, 5. 5 when divided by 3, remainder 2. If you check it out, 5. 5 when divided by 3, 3 ones are 3, remainder 2. Each and every key point, whatever I am explaining, in addition to the problem, make a note in your notebook. Make a note in your notebook. This will be extremely useful if the question complexity increases and you are unable to find out by using method 1. Sometimes answer options can help you to tell the better approaches. Please remember, answer options are not only given to tick mark, answer options are also given to be used sometimes. I hope the idea it is clear. Each and every question in detail concept. Next one. All the questions we cleared now. Which least factorial it is divisible by 9, 10? Which least factorial it is divisible by 9, 10? Now see here. Which least factorial? Which least factorial divides is divisible by first one 21, second one 33, third one it is 68. First we will solve this question. Which least factorial is divisible by 21? 21 it is 7 into 3. 7 into 3. That means in factorial, in the factorial, I should get 7. In factorial, I should get 7. What is the smallest natural number, right, which will have factorial as a 7? Or what is the minimum power of 7? 7 power 1 I should get. I will get it in 7 factorial. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. 3 into 2 into 1. So 721 contains 1 power of 7 and 1 power of 3. What is the factorial that will have 1 power of 7? That is 7 factorial. 33 it is 11 into 3. 11 into 3. If the given number it is a composite number, write down the composite number as a product of co-prime numbers, take the highest number. Highest it is 11. Which factorial will have 1 power of 11? Which is 11 factorial. 11 into 10 into 9 and so on up to 3 into 2 into 1. 11. If it is 68, 17 into 4. 17 into 4. 17 should be present. So 17 power 1 is present in 17 factorial. 17 and so on. 17 and so on. So answer, which least factorial is divisible by 21? 7 factorial. Now if you see here, suppose if I take till here, is there 7 present in that number? No. So what is the least factorial which will have 1 power of 7? That is 7 power 1. So 7. Anyway, factorial means I have to write from 7 to 1. 3 will be present. 11 and it will be 17. I hope the idea it is clear. Is the idea it is clear? Now, if you see here, suppose if the question is 98, if the question is 98, what is 98? 98 it is 7 square into 2. 7 square into 2. So what should be the minimum power of 7? 2. But here in 7 factorial, only 1 power of 7 I got. What is the next multiple of 7? 14 factorial. So what will be the answer? 14 factorial. Why? Because it is 14 into 13 into 12. And so on up to 7 into 6 and so on up to 1. It is 7 into 2. 1 power of 7 we got here. And here also 1 power of 7 we got here. So 7 into 7. 49. Anyway 2 will be present. I hope the idea it is clear. Suppose if the question is 27. 27. 27. Easily you can do. 27 is 3 cube. 27 is 3 cube. That means power of 3 should be 3. Power of 3 it is 3 means 3 into 3 into 3. 3 into 3 into 3. First 3 will come in 3 multiple 1. Next 3 will come in 3 2s are 6 multiple. Next 3 will come from, if you see, 3 cube. 3 cube, if you see, here 1 power of 3 it is there. Here it is another power of 3. 1 plus 1 it is 2. Suppose if I take 9 factorial, 9 into 8 into, 7 into, 6 into, 5 into, 4 into, 3 into, 2 into 1. 1 power of 3. It is 3 into 2, 2 power of 3. Here it is 3 square. In fact, it is divisible by 3 power 4. Any number divisible by 3 power 4 is also divisible by 3 cube. So answer for this question is 9 factorial. 9 factorial. I hope it is clear. Is the idea clear? 21, it is 7 into 3. 7 into 3. 21 contains 7 and 3. 1 power of 7 should come. So the least prime number which will have factorial having 7 is 7 factorial. The same question can also be asked like this. The same question can also be asked like this. Remainder 13 factorial divided by 11 power x equivalent to how much? Remainder 1, 13 factorial divided by 11 power x, how much? Introductory question. 13 factorial is product of all natural numbers from 13 to 1. It contains 11. It contains 11. It is equivalent to 0. X equivalent to how much? 1 power of 11. 13 factorial divided by 11 power x, it is 0. 13 factorial is product of all natural numbers from 1 to 13. How many powers of 11 are there? 1 power of 11 it is there. X equivalent to 1. Are you all with me? Suppose if the question is 10 factorial divided by 3 power x, it is 0. I will do in detail how to find out the highest power. 10 factorial divided by 3 power x, it is 0. Find x. 10 factorial it is defined as 10 into 9 into 8 into 7 into 6 into 5 into 3 into 2 into 1. Only the concentration is on power of 3. I will take this. I will take this. I will take this. 9 it is 3 square. Here it is 3 into 2. 3 power 1. Here it is 3 power 1. So total it is 4. X equivalent to 4. X equivalent to 4. Is the idea clear? Is the idea it is clear to you? Is the idea it is clear? 10 factorial. But doing all these, it is a time consuming process. That is the reason we will do a successive dividing by the power. That I will explain it in the next class. Sorry, in the next slide. 13 factorial divided by 11 power x. 13 factorial contains 1 power of 11. X equivalent to 1. 10 factorial contains 3 1s are 3, 3 2s are 6, 3 3s are 9. 3 3s are 9. 3 square, 1 power of 3, 1 power of 3. 3 power 2 plus 1 plus 1. It is 3 power 4. So x value will be 4. X value will be 4. X value will be 4. Now see here. Which least factorial is divisible by? That means question he is asking. X factorial is divisible by 9, 10. Perfectly divisible, right? Perfectly divisible means remainder should be 0. Remainder should be 0. In mathematical format, x factorial divided by 9, 10. Remainder it is 0. First thing, 9, 10. 9, 10 factorize it. 7 into 130. 7 into 13 into 10. 10 it is 2 into 5. So if I write it in ascending order, 2 into 5 into 7 into 13. 2 into 5 into 7 into 13. It's what is the highest prime number? 13. 13 will come in which factorial starting onwards? 13 factorial onwards. X is 30. X is 13. When you are writing 13 factorial, all the numbers will come from 13 to 1. 13, 12, 11 and so on up to 3 into 2 into 1. 13 will come, 7 will come, 5 will come and 2 will come. Only take the highest prime number and attach that factorial. 13 factorial. Is the idea clear? We will do some more questions based upon this one. Suppose if the question is remainder x factorial divided by 119, it is 0. Find x. Remainder x factorial divided by 119. Reminder, it is 0. 119, factorize it. It is 17 into 7. 119, it is 17 into 7. What is the highest prime number? 17. So 17 factorial when divided by 119, it will be 0. Each and every question, if I think that it is a new question, then I'll create some other question so that it will be extremely clear to you. Is the idea clear? X factorial divided by 119, it is 0. 119, it is 17 into 7. So X value should be 17. X value should be 17. First question. First, second, Chinese remainder theorem application. Then factorial, which least factorial questions. Now see here. Write down this approach. We will fill the entire PPT with as many concepts as possible. Highest powers concept. Highest powers concept. Write down, sir. Highest powers concept. Listen carefully. Very, very interesting concept, sir. Highest powers. Once you understand these highest powers, in the trailing zeros, I will discuss a very, very important key point. Most of the textbook says that number of zeros at the end is always the highest power of 5, which is wrong for some problems. I will tell you why the highest power of 5 will not give you number of zeros at the end. Number of zeros at the end is also dependent on the power of 2, which I'll explain it in trailing zeros class. Highest power concept. Listen carefully. Suppose if I write 4 factorial, it is 4 into 3 into 2 into 1. Step number 1. From 1 to 4, what are the prime numbers that are present? 2 and 3. First point. Natural number n. Please write down this point. Natural number n can be written as a power of prime basis. Can be written as power of prime basis from 1 to n. Make a note of this point. Obviously, it will be from 1 to n. So, it cannot be greater than n. So, every natural number n factorial. Every natural number n factorial can be written as a power of prime basis from 1 to n. Each and every question is extremely important from this slide. Natural number n factorial. Now see here. 4 factorial. What are the prime numbers from 1 to 4, 2 and 3? So we are telling that it can be written as 2 power x and 3 power y. We need to find out the value of x and y. We need to find out the value of x and y. When I say the heading as highest powers, if there is a 20 factorial, from 1 to 20, what are all the prime numbers? 2 power, 3 power, 5 power, 7 power, 11 power, 13 power, 17 power, 19 power. That highest power of that prime number is what we are determining. I hope the value of x is what we are determining. Value of y is what we are determining. So if I think logically, 4 into 3 into 2 is 24. 24 is 2 cube into 3. Because it is a smaller value. It is a smaller value. Directly you can write it as 2 cube into 3. What if it is 20 factorial, 30 factorial, 50 factorial, 90 factorial, 100 factorial? It will be difficult. So what we will do is, we will divide with the factorial first with the first prime number. 2 2s are 4. What does it? These two signifies. These two signifies there are 2 multiples of 2 from 1 to 4. 2 1s are 2, 2 2s are 4. 2 1s are 2, 2 2s are 4. These two signifies that there are 2 multiples of 2. Again, divide it by 2, 1. These signifies there is 1 multiple of 4. There is 1 multiple of 4. Think logically. 2 is 2 1s are 2. 4 is 2 2s are 4. Here 1 power of 2 is there. Here 1 power of 2 is there. Every power of 4 is also a power of 2. Here another power of 2 it is there. So 1 plus 1. Here 2 denotes there are 2 multiples of 2. Every power of 4 is also a power of 2. These 1 denotes there is 1 multiple of 4. Please write down that point. There is 1 multiple of 4. These 2 denotes there are 2 multiples of 2. There are 2 multiples of 2. There are 2 multiples of 2. I hope the idea it is clear. Why we are dividing it should be clear to you. Why we are dividing it should be clear to you. Similarly for 3, divide these 4 by 3. 3 ones are 3. What does this 1 mean? 1 mean there is 1 multiple of 3. There is only 1 multiple of 3, which is 2 cube into 3. I hope the idea it is clear. Again, I am repeating important key steps. A factorial can be written as a power of prime bases from 1 to n. It can be written as a power of prime bases from 1 to n. 1 to 4 I wrote. 1 to 4 product will give you 4 factorial. What are the prime numbers from 1 to 4? 2 and 3. So I divided it with 2. 2 2s are 4. There are 2 multiples of 2. Again I divided it with another power of 2. 2 2s are 4, because every power of 4 is also a power of 2. Every power of 9 is also a power of 3. Every power of 25 is also a power of 5. I hope the idea it is clear. Every natural number n factorial can be written as a power of prime numbers. Power of prime numbers from 1 to n. Entire class is based upon this single key point, sir. Every natural number n factorial can be written as a power of prime bases from 1 to n. Now see here. Now we will do a simple question. Highest power of. In this question I will write down everything in detail. Then I will optimize it. 8 factorial. 8 factorial is product of all natural numbers from 8 to 1. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. 8 factorial it is. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Every natural number n factorial can be written as a power of prime bases from 1 to n. N it is 8. So it can be written as 2 power something, 3 power something, 5 power something and 7 power something. These x, y, z value is what we need to determine. X, y, z value is what we need to determine. First we will go with 2. 8 factorial. Take this 8. Divide it with 2. So I got 4. What is that 4? 4 says that there are 4 multiples of 2 when you are writing the natural number from 1 to 8. 4 multiples of 2. 2 1s are 2. 2 2s are 4. 2 3s are 6. 2 4s are 8. That is what 4 denotes. I hope the idea it is clear. Next one. Suppose if I divide it again by 2. 2 2s are 4. What does that 2 denotes? 2 denotes that there are 2 multiples of 4. Every power of 4 can also be written as a power of 2. 2 denotes that there are 2 multiples of 4. I am writing here. This one and this one. 4 is 2 into 2. Extra it will come. Again further divide. 2 1s are 2. There is 1 multiple of 8. Power of 8 will have power of 2 also. So what is that one? This is nothing but 8. I hope what I wrote down, it is clear to you. It's extremely important for you to understand why we are adding this. 4 plus 2 plus 1. 4 plus 2 plus 1, it is 7. Now see here, why we are adding. First it is 2 1s are 2. Next it is 2 2s are 4. Next it is 2 3s are 6. Next it is 2 4s are 8. I want the highest power of 2. So 1, 2, 3, 4. I did 4. Next, here also it is 1 power of 2. 4 it is 2 into 2. Now if you see, there are 2 here, there is 1 here. So 2 into 2 into 2. I got 2 cube here. 3 plus 1 plus 2 plus 1. So total how much I got? 7. Why we are adding a power m into a power n is a power m plus n. So when you are doing the power of 2 in multiple numbers, the powers will get added. 4 plus 2 plus 1, answer is x equivalent to 7. I hope the idea it is clear. Every factorial can be written as a product of prime basis. For 3 we want divide by 3. 3 2s are 6. 3 2s are 6. Again there are 2 multiples of 2. By this time you should have understood this one. Again there is no power of 9 here. If I do 3 0. Power of 9 it is not there. 6 is 3 into 2. 3 into 1, 3 into 2. Another power it is not there. So stop it here. So it is 3 square. Similarly it is 5 power 1, 7 power 1. So 8 factorial can be written as 2 power 7 into 3 square into 5 power 1 into 7 power 1. What is the highest power of 2? Answer is 7. Highest power of 2, answer is 7. I hope this idea it is clear. Why we are doing it successively and adding? I am adding it. Why? Because if it is multiplied 2 power 1, 2 power 1, 2 power 1, 2 power 1, 2 power